Okay, let's just dive right in. If you've ever worked with data, you know the one big truth. Real-world data is almost never perfect. It is messy, it's inconsistent, and it is full of surprises. So today, we're going to tackle that chaos head-on, and we're going to do it using the super powerful Hugging Face Datasets library.
I mean, seriously, have you ever opened a CSV file and just sighed? You've got these weird columns with no names, text that's all over the place, missing values. It's a feeling every single one of us knows. And that's exactly where we're starting today. So, we're going to be working with the Drug Review Dataset from UC Irvine. And right off the bat, you can see it's got its quirks. There's this mysterious, unnamed zero column that really looks like it should be a patient ID. Then you've got the condition labels and their total mix of uppercase and lowercase. The reviews themselves, they're filled with these weird HTML character codes. And maybe worst of all, some of the values are just gone.
So here is our game plan for this journey. First, we're going to face the raw data and figure out what we're dealing with. Then we'll move into some basic cleanup. After that, we'll actually start enriching the dataset by creating some brand new columns. Then we get to the fun part, unleashing the real superpower of this library, the .map method. And finally, we'll wrap it all up by saving our beautifully clean data. Sound good? Let's go.
All right, section 1, the challenge of wrangling raw data. Look, before we can fix the mess, we have to really understand it, right? So our very first step is to just load up the dataset and get a good, clear look at all those problems we just listed. That's how we'll create our plan of attack.
Okay, so we've identified our problems. Now it's time to roll up our sleeves and actually start the cleanup. We're going to start by tackling the low-hanging fruit first.
Our first few moves here are pretty straightforward. We'll use the .rename_column method to give that weird unnamed column a proper name. Patient ID. Easy enough. Then we'll write a simple function and use .map to make all the condition labels lowercase so they're all consistent. But when we go to run that,
bam, an error. The whole thing breaks. And you know what? This is so common when you're wrangling data. But the error message, it tells us everything we need to know. We tried to call the .lower method on something that wasn't text. It was a none-type object. That means some of our rows just have no condition listed at all.
So what's the best way to solve this? The most elegant way? We need to filter out any row where the condition is just empty. I mean, we could write a whole separate function for this, but there is a much, much cleaner way. Let's talk for a second about lambda functions. Just think of them as these tiny little disposable functions that you don't even have to give a name to. They're absolutely perfect for small, single-use jobs, kind of like the one we need to do right now. And the syntax is just beautifully simple. You just use the keyword lambda, you list your inputs, add a colon, and then you write the expression that you want to run. It's a one-liner that really packs a punch.
and this is where their power just shines. We use the .filter method, and we pass it a lambda function that does one simple thing. It checks if a condition exists. That's it. One single line, and our problem is solved. The empty rows are just gone.
Okay, so now that we've cleaned up the data that was already there, it's time to start enriching it. So in this next section, we're going to see how to create entirely new columns that make our data set even more powerful. You know, a really common thing you want to do with text data is check its length. Well, we can write a quick function to count the words in a review, and then using .mapping, just apply that function to every single row in our data set. And the library is smart enough to know this should be a whole new column, and it even names it for us, review link. So, why did we do that? What was the point? Well, now we can use this new column to improve the quality of our data. You see, some reviews are just one word, like great, which, let's be honest, isn't very useful for training a model. So now we can use .filter again to keep only the reviews that have, say, 30 words or more. All right, one last little piece of basic cleaning. Remember those weird ampersand codes we saw? Well, that's just an HTML code for an apostrophe. We can use Python's built-in HTML module and, you guessed it, the .map method to just sweep through all the reviews and convert those codes back into normal characters. Okay, look, we've used .map quite a bit so far, but we've really only been scratching the surface. Now we're going to unlock its true potential. This is where HD datasets really goes from just being useful to being absolutely essential. Now, you might be thinking, hold on, applying a function to every single review, one by one, on a dataset with thousands or even millions of rows, Isn't that going to take forever? And you know what? You would be absolutely right. But what if we didn't have to do it one by one? This right here, this is the secret weapon. By adding one single, simple argument to our .map call, batched equals true, we tell the library, hey, don't send my function just one example. Send it a whole batch of examples at once, usually about 1,000 of them. And here's the result. Just look at that difference. Processing the reviews one by one took nearly a full minute, but by processing them in batches, it took just under 11 seconds. That is over a 5-time speed up just from adding one little argument. And guess what? We can go even faster. If your machine has multiple CPU cores, you can tell .map to use them by setting the numproc argument. This basically splits up the work and does it in parallel, squeezing every last bit of performance out of your hardware. When you combine batching with multiprocessing, you can take tasks that might have taken several minutes and get them done in under a minute. It's amazing. But here is where .mapping gets truly wild. It can even change the number of rows in your dataset. Imagine you have one really long review, and you want to split it into 3 smaller chunks. Well, now you have a problem. 1 row went in, but 3 came out. What do you do with the original data, like the patient ID? Well, mapping gives you 2 great options. You can either just remove those old columns for a super clean result, or you can have it duplicate the original data for each of the new chunks. It is incredibly flexible.
And we've done it. The data is clean, it's enriched, and it's been processed at lightning speed. All that's left now are just the final touches to get it ready for training a model and, of course, to save all of our hard work.
And the library makes these last steps so easy. Need to do some complex data analysis or visualization? Just use .set format to instantly switch your dataset's output to a pandas data frame. Need to create a validation set for your model? The .train test split function handles that for you in a single line. And when you're all done, you can save your pristine dataset to disk in the super efficient arrow format, or of course in classic CSV or JSON.
And that is it. We took a messy, difficult, real-world dataset, and using the powerful and efficient tools in Hijazi datasets, we completely transformed it into a clean, model-ready asset. We have officially tamed the chaos. So the only question left to ask is, now that your data is ready, what are you going to build?